Welcome to this explainer. Okay, so think about the date July 28th. On the surface, it's just another ordinary day on the calendar, right? Just a completely random 24 hours. But if you dig into the history of mathematics, you'll actually find that this single date secretly built the modern digital world we're living in right now. It is genuinely one of the most important dates in math history, and today we're going to uncover the hidden connections that prove it. Let's get into it.
Okay, let's dive into this. We're looking at four pivotal moments. Gaspard Monge in 1818, John Bell, born in 1928, István Fenyő in 1987, and Caleb Gattegno in 1988. Four brilliant minds, completely different centuries, completely different countries. They never met, but their ideas are seamlessly interacting inside your smartphone, your computer, and even your brain right now. We're going to play historical detective today and untangle this whole timeline.
So, to start us off, have you ever actually stopped to wonder how your favorite video games render these massive, realistic 3D worlds right onto our perfectly flat screens? Think about it. Our monitors only have two dimensions, just height and width. So how in the world do developers trick our brains into seeing deep, explorable landscapes with mountains and shadows?
Well, the answer actually traces all the way back to July 28, 1818, with the passing of a brilliant French mathematician named Gaspard Monge. Now, long before electricity, let alone computers, Monge was absolutely obsessed with a specific puzzle: how to accurately represent our three-dimensional physical world on a two-dimensional sheet of paper. He ended up inventing this pioneering field called descriptive geometry. Instead of just guessing how a 3D object might look and roughly sketching it out, Monge created a strict mathematical system to project the lines of a 3D shape onto flat 2D planes. It's kind of like casting a super precise shadow on a wall using a flashlight. By figuring out the exact equations for how lines intersect and project onto a flat surface, he unknowingly wrote the foundational rules for literally all modern 3D computer graphics. Your computer's graphics card is essentially doing Monge's math millions of times every single second.
I mean, just think about that for a second. Every single time you explore a stunning 3D video game environment, your modern machine is fundamentally relying on the flat paper geometry devised by a guy in the 1800s. It really makes you look at your screen differently, doesn't it?
Let's move to and see how this builds from Monge in 1818 all the way to John Bell in 1928. We're jumping exactly 110 years into the future for a truly mind-bending idea that takes us out of geometry and straight into the weird world of quantum physics.
You've probably heard a lot of buzz lately about the unhackable quantum internet of the future. But how is that actually going to work? How can two computers share information instantly and invisibly across thousands of miles without any hacker or spy being able to intercept the signal in between?
The blueprint for that sci-fi future goes right back to the birth of a physicist on July 28, 1928, a man named John Bell, who was bold enough to dare to challenge the absolute greatest scientific minds of his time.
Now, what's really interesting about this is how Bell found himself right in the middle of a fierce debate, taking on Albert Einstein himself. See, Einstein wanted the universe to be predictable. He notoriously hated the idea of particles communicating magically, which he called spooky action at a distance. But Bell proved mathematically that certain hidden variables must be non-local. In plain English, he proved that particles truly are entangled. They are secretly, instantly connected across any distance. If you measure one particle here on Earth, its partner reacts immediately, even if it's all the way on Mars. No physical signal passes between them. And that mind-bending proof is the exact mechanism that's going to power our future quantum internet, because there's literally no signal for a hacker to intercept.
So as it turns out, the universe is not just stranger than we imagine, it is instantly connected. John Bell's mathematical proof of these quantum secrets is the absolute bedrock for tomorrow's most secure technologies. And again, it all anchors back to our golden date.
All right, jumping back to the timeline. From 1928, we're fast-forwarding to the late 1980s. This is where our golden date shifts focus. We're moving from how computers and particles work to how we, humans, actually learn and process complex information.
Think about your favorite language or math learning apps on your phone right now. Why do they use vibrant colors, sliding shapes, and dragging blocks, instead of just making you stare at boring abstract numbers and rigid equations? Why does playing with physical or digital objects feel so much more natural to our brains?
That incredibly intuitive design goes back to the passing of Caleb Gattegno on July 28, 1988. He was a self-taught mathematical genius and honestly a total educational maverick. He firmly believed anyone could master complex subjects if they were just taught differently.
So the crucial point is how Gattegno popularized these physical, color-coded blocks called Cuisinart rods. Think about how revolutionary this is for a kid's brain. Instead of writing abstract, boring symbols like 2 + 2 = 4 on a chalkboard, a child could physically snap together a red block and a white block to perfectly match the length of a green block. He literally turned invisible math rules into tangible objects you can play with. This completely bridged the massive gap between abstract thinking and physical doing. It revolutionized early education and created the direct blueprint for almost every single digital learning app interface we tap on today.
He proved that anyone can learn math when we can see and touch the numbers. It's just a powerful reminder that our minds are incredibly fast when dealing with visual puzzles and spatial reasoning. Modern app developers know this, and they use it to keep us happily learning every single day. Okay, checking our timeline one last time. We are actually going to step just one single year backward from Gattegno to 1987 to meet our final mathematical detective, the person who solved the absolute chaos of your modern commute.
Have you ever marveled at how your phone's GPS map can instantly calculate the absolute fastest route through millions of tangled city streets? Automatically avoiding traffic jams and construction in real time? How does it make sense of that sheer volume of data in a fraction of a second?
Well, the mathematical foundation for that daily miracle points right back to July 28, 1987, and the passing of a brilliant Hungarian mathematician named István Fenyő. And this brilliantly illustrates network theory and linear algebra, because Fenyő was an absolute master of unifying complex systems. He brought these fields together to create the ultimate frameworks for analyzing massive, chaotic webs of data. To visualize this, just think of a massive city grid as thousands of dots, the intersections, connected by lines, which are the streets. The math Fenyő formalized gave software engineers the exact tools and equations they needed to translate that physical map into a grid of numbers that a computer can process instantly. It calculates the most efficient path between any two dots in a massive network. That exact math is the beating heart of the routing algorithms navigating your car right this very second. The absolute chaos of city traffic is perfectly tamed by the hidden, elegant paths of network math. It is living proof that mathematics truly is the ultimate navigation tool for the modern world.
All right, now let's take a step back and bring all four of these incredible historical figures together: Monge, Bell, Fenyő, and Gattegno.
Just look at the staggering impact of this single calendar date. July 28th gave us the foundations for the 3D video game graphics we love, the mind-bending reality of the future quantum internet, the colorful visual learning apps on our phones, and the GPS network routing that gets us safely home. Every single brilliant mind we met today across completely different centuries and countries was united by the exact same quest, looking at chaos and finding the beautiful mathematical pattern hiding inside it. So, I'm going to leave you with this provocative thought as you go about your day. Where is the hidden mathematical pattern waiting to be discovered in your own everyday life? What seemingly random things are actually deeply mathematically connected? Keep your eyes open, keep asking questions like the detective, and I'll see you in our next explainer.